In this video, we're talking about what biomedical engineers do, and we're starting right now. Hey 1% Nation, I'm Jake Voorhees, and welcome back to the 1% Engineer Show, where we empower young engineers to rise to the top 1% of their career. So if you're a young engineer and you want to be successful, then make sure you subscribe.
And hit the bell. We need you to hit the bell too.
If you don't know about it yet, we have a Discord server just for 1% Engineer. Find the links in the description. And if you want the 1% Engineer Kit, which is 5 free ebooks and resume templates for your success, follow those links too. So let's get started. Biomedical engineers design, develop, test, research, and may supervise the manufacturing and/or installation of healthcare equipment, components, or systems for commercial, industrial, or military use. And don't forget about science, of course not that. Biomedical engineering is a hugely broad field with an array of job roles in very specific industries. From medical devices to hospitals and other clinical settings, biomedical engineers are an integral part of advancing healthcare. Later, we'll discuss subgroups within biomedical engineering, but really, the key is that it's anything in healthcare in general. A biomedical engineer is someone who applies physics and mathematics to design and develop new healthcare equipment and systems, to then solve problems and to test equipment. The emergence of a longer human lifespan is noted by the improvement of therapeutics and development of medical devices such as the artificial pacemaker. Really quickly guys, I want to go over the difference between bioengineering and biomedical engineering. That question gets asked a lot online. Though the two phrases may just roll off the tongue similarly, in practice there are notable differences between the two. Bioengineering is the study of applied engineering practices in general biology. It is the more broad topic when compared to biomedical engineering, as bioengineering covers agriculture, pharmaceuticals, natural resources, the food industry, and many other things. In addition, bioengineering covers general medical practices, though biomedical engineering focuses more on this field than general bioengineering. Bioengineering practices are applied to many different industries, including healthcare, but bioengineering practices are not explicit to medical purposes. Okay, now that you know the difference between bioengineering and biomedical engineering, I'd like to go over a brief history with these videos. Historically, early forms of biomedical engineering would have been things that seem so antiquated today. For example, the first prosthetic toe was found in ancient Egypt more than 3,000 years ago. The pharaohs had biomedical engineers. Eventually, the artificial pacemaker came along, the hearing aid, the artificial heart, things like this. Today, modern biomedical engineers work in many fields, which may include technology, manufacturing, pharmaceuticals, and research. Like many fields, guys, biomedical engineering is another one where you can work in many sectors, many industries. So keep in mind hot topics and cool lanes, things like right now, there's a lot of people who are interested in biomedical engineering because it is these types of engineers who will create a vaccine, who will be researching with the fight against COVID-19 and ways that we can be more prepared for a global pandemic next time. If you want to be a biomedical engineer, you probably want to fix some sort of human healthcare problem. What problem is it? Comment below. I want to know. Okay, with that brief history, let's go over some of the tasks and duties that you may be doing as a biomedical engineer. When you begin any engineering career, you start off with learning the fundamentals of whatever industry you are in. So you may be doing any of these tasks or duties. A biomedical engineer may design biomedical equipment and devices, such as artificial organs, replacement body parts, and machines for diagnosing medical problems. They may install, adjust, maintain, repair, or provide technical support for biomedical equipment. They may evaluate the safety, efficiency, and effectiveness of biomedical technology. They may train technicians and other personnel on the proper use of biomedical equipment. They may research the engineering aspects of the biological systems of humans and animals with life scientists, chemists, and medical scientists. They may prepare procedures, write technical reports, publish papers, and make recommendations based on their research findings. And finally, biomedical engineers may present their research to scientists, non-science executives, clinicians, hospital executives, engineers, politicians, colleagues, and more. So it's pretty broad. If you're interested in biomedical engineering or any other type of engineering, you're constantly trying to narrow your niche within this field. So if you find yourself drawn to biomedical engineering, which part of that industry do you like? Do you want to design devices? Do you want to do research? Do you want to work for corporate? Do you want to hunt down the creation of vaccines? You get to choose. There's a wide array of tasks and duties. You have to take your career and your future in your own hands and find the perfect job for you. Okay, now that you have some duties and a little bit of advice from me, like most engineering fields, biomedical engineering consists of several subfields. Again, civil has 5 and mechanical has 12. Starting off with subfield number 1, bioinformatics. Bioinformatics is the use of computers, software, and related technologies to develop methods to better understand biological data. Applications of this include,
but are not limited to,
image diagnosis tools, protein and gene expressions, and sequence analysis. Field number 2, biomechanics. One of my best friends was studying anatomy and biomechanics in order to get into physical therapy school in grad school, and I was always so interested in his courses, which to me in a way was the combination of our anatomy and physiology with almost like an engineering way that our body and skeletal structures and our physical anatomy starts to work together. And here we are, of course, we're talking about it as a subfield. Biomechanics is the study of the structures and functions of the mechanical aspects of biological systems at any level, from whole organisms to organs, cells, and cell organelles. All of this studying uses the method of mechanics, and one of the biggest applications of biomechanics is to design orthopedic implants for human joints, dental parts, and other medical purposes. Field number 3, biomaterial. Biomaterial is any matter, surface, or construct that interacts with living systems. It is a growing field, with many companies investing in this field to create resources to develop new products such as heart valves, breast implants, and contact lenses. Field number 4 is tissue engineering. Tissue engineering is the application of engineering to tissues, which is a group of cells. One big focus is the creation of tissue to solve organ donor problems and create artificial organs. I just Googled the duration of the waiting list for organs and it says up to 5 years. Imagine that if you or a loved one was diagnosed with liver failure or only has 1 kidney or needs a replacement heart, you could die on the waiting list. So the creation of artificial organs is a great advancement in human healthcare. Thanks to biomedical engineers! Current success in the field includes the creation of artificial urinary bladders, solid jawbones, and we can even make artificial windpipes. Field number 5 is genetic engineering. Genetic engineering is gene splicing and genetic modification of genetic material to create new products and solve genetic diseases such as cystic fibrosis, sickle cell anemia, and so on. Synthetic human insulin has even been created. By altering genes, and in the future, personalized drugs will even come out using a personalized DNA method that creates the most effective drug for that specific individual. Pretty crazy, guys. Custom drugs? What? Subgroup number 6 is pharmaceutical engineering. Pharmaceutical engineering is the application of engineering to drugs to create new drugs or optimize existing pharmaceutical products. Examples of pharmaceutical engineering include the discovery of things like penicillin, sustained release pills, which allow for drugs to be slowly released in the body for over a 24 to 48 hour period. And finally, these types of engineers work on the mass production of drugs. Even though the United States has a massive pharmaceutical industry, if you pay attention to a lot of thought leaders and futurists out there, we will see fewer and fewer uses of pharmaceutical drugs from a worldwide perspective. So I'm not very bullish, not very positive, not very optimistic on pharmaceutical engineering in general. It's most likely going to be around for 20 to 40 years, but no different than chemical engineering or petroleum engineering, especially petroleum engineering. I think pharmaceutical engineering is a little bit fragile, or it may be one of those sectors, kind of like how we look at coal today. Yes, of course, once upon a time it had its place, but those days are over. The 7th subfield is medical devices. Medical devices are the creation and optimization of instruments such as artificial pacemakers, medical imaging devices like CAT scans, MRIs, and so on. Also, this includes medical sensors and bionics, which are replacements for enhancements of organs with a mechanical version. Subfield number 8 is clinical engineering. Clinical engineering is the implementation of medical equipment and technology in hospitals or other clinical settings. Clinical engineers train technicians and manage implementation. These engineers can be thought of in one way as industrial systems engineers within healthcare. Finally, we have rehabilitation engineering, the 9th subgroup. Rehabilitation engineering is the systematic application of engineering sciences to design, develop, adapt, test, evaluate, apply, and distribute technological solutions to problems confronted by individuals with disabilities. One example of this is creating or optimizing a prosthetic leg. All right, with that covered, let's talk about the work environment for biomedical engineers. Biomedical engineers work in many different environments. These include medical devices, research and development labs, higher education, instrument manufacturing, and finally, hospital and clinical environments. Biomedical engineers work in teams with scientists, healthcare workers, or other engineers. depending on where and how they work on the project. For example, a biomedical engineer who has developed a new device designed to help a person with a disability to walk again might have to spend hours in a hospital to determine whether the device works as planned. If the engineer finds a way to improve the device, they might have to return to the manufacturer to help alter the process to then improve the design. There's a great element of job security in the world of biomedical engineering. This is due to the fact that people are living longer and more solutions are needed to survive this length of time, and because people and governments are willing to spend money on human health. All right, let's talk about the PE exam. In these what do X type of engineers do, I love to cover should you become a professional engineer or not. And this is another one where very few engineers actually become a PE within biomedical engineering. It's such a brand new field, so there just wasn't as much of a system for an engineer to create a stamp to then design a physical device. And unless you're actually designing a physical device, you don't technically need your PE if you're conducting research or maybe even optimizing an existing design. Again, guys, I need to say this, there are some biomedical engineers who will get the PE. It will benefit them and they will not regret it. Really quickly, let's talk about this. In engineering, there's always two paths. I have plenty of videos about this. There's a technical thought leader, and then there's a team leader who is destined for management. This type of person gets their MBA if they want. This type of person gets their master's degree, master's of science or master's of engineering if they want. That's the split. These types of biomedical engineers who are leaders, managers, are going to end up running a department one day. Getting your PE shows your ambition. It shows one more certification. It shows your willingness and thought processing around standing out, and it will help you in your career. So if you're a communicator and not just a technical figure it out type of R&D person, then still get your PE. But otherwise, just like software, electrical, computer engineering, chemical engineering, you don't really need it. An FE on your resume never looks good when you're applying to your first jobs.
Bad. It never looks bad. Ugh. Of course I misspeak there.
So I always encourage people to do that. And then 4 years down the road after working, you can decide if you want to actually sit for the real PE. The grand finale of this biomedical engineering video is just talking about the future, guys. There's a book out there called The Singularity. It's written by Raymond Kurzweil, and I think this concept, where we're headed as a human species, is really important for biomedical engineers to consider. Because what's really happening, guys, is we're on the back of millions and millions of years of human evolution to get to today. However, our technological evolution has happened so quickly that in order for us to advance, in order for us to outpace AI and robots, in order to continue this trend and keep up with our own technologies, we have to have this integration of our biological evolution and our technological evolution, which is why we see nanobots in our bodies, which is why we see artificial organs and limbs in our bodies. It's why we look at companies like Elon Musk that actually can amplify how our brain works. So we will see these insane, futuristic, and long-reaching technologies that come out surrounding our human health, and it's biomedical engineers who make this happen. So if you're excited about being on the forefront of our human physical health and our technological evolution of our healthcare, then this is the perfect field for you. I want to give a huge shout out to Hamza Wahid, who wrote this script and who's also on the core team of 1% Engineer. Thank you so much, guys. If you're interested in joining the team, I have 5 or 6 engineers who are becoming a part of this family and working on things and getting experience on their resume and can put 1% Engineer on their LinkedIn during this time. It can actually be a virtual internship. So if you're interested, comment below. I hope this video helped you guys. What do biomedical engineers do? I got a lot of questions about this. Thanks again for watching the 1% Engineer Show, guys. If you're a young engineer and you want to rise to the top 1% of your career, then make sure you hit the bell and subscribe. Follow the links below for the Discord, and if you want 5 free ebooks, you can find the 1% Engineer Kit down below as well. Thanks again for watching the show, guys, and we'll see you again in another video. Bye-bye.